This example is one that really indicates the power of the compounding period in the determination of interest. So each of these investments is basically the same. Celine's investing $3,000, show that she can buy a car in the next 5 years, and every investment pays 4.8%, compounded annually, semi-annually, monthly, weekly, or daily. And to compare the value of the investment after each time, we need to calculate each one out. So it is quite a bit of calculation, but it is basically the same here. So no matter what, we know that she will be investing $3,000. We know that the time she's looking at will be 5 years. And we know that her interest rate will be 4.8% or 0.048. I'm going to flip to the next slide to do the work. If we deal with A, compounded annually, what happens is we have n equals 1 compounding period per year. Writing out the formula. We know principal of $3,000, R 0.048, n is 1, exponent is 1 times 5. Working this out, 0.048 divided by 1 is 0.048. Exponent is 5. And I need to make a correction. I have plus signs in here, which should not be there. My fault. This is multiplying. Inside the bracket, we get 1.048. (1.048) to the power of 5 is 1.264172717. And that gives us a total of $3,792.52. Scenario B, we're compounded semi-annually, which means twice per year. So we can go into the equation. P is still 3,000. R is still 0.048. But now n is 2. So the exponent will be 2 times 5 then. .048 divided by 2 is 0.024 the power of 10. One plus 0.024 is 1.024 to the power of 10. (1.024 to the power of 10 is 1.2676506. Which gives us a total of $3,802.82. $2,000,000.95. So you can see already, even by going from one compounding period per year to two, we've gained an extra $10. Scenario C, we are monthly, which means there will be 12 compounding periods per year. Going into the formula, P is still 3,000, R is still 0.048, N is now 12, so the exponent is 12 times 5. And just in the interest of saving some time, we won't go through the calculations because it is all going to be the same. This one works out to $3,811.92. Flip over for D and E. In D, we're dealing with being compounded weekly, so 52 times per year. I'm going to do a little bit more detail on this one compared to example C, just because of one thing that does come up. So 3,000, 1 plus 0.048 over 12 to the power of 52. Oops, not divided by 12, divided by 52. Power of 52 times 5. Now, the issue that comes up in a question like this is when we do 0.048 divided by 52, most calculators will give this in scientific notation. If your calculator doesn't, that's fine, and just carry on. But when I put this into my calculator, I'm just going to do it in red up here, I get 9.23076, 9231 with an E -4. Now this is calculated shorthand. What this really means is 9.23076, 9231 times 10 to the -4. And scientific notation is just a shorthand way of writing either really large numbers or really small numbers. This happens to be a small one because the exponent is -4. What that means is the decimal was moved 4 places to the right to make this number work. So to convert it back to a standard decimal, we would move the decimal 1, 2, 3, 4 places. The decimal would be here. Fill in with zeros. So this number as a standard number would be 0.0009230769231. And that is what 0.048 divided by 52 is. Just a hiccup that comes up when we have a lot of compounding periods per year. This does make the decimal work out in scientific notation. Just know you will need to deal with it, and this is how. The exponent, 52 times 5, is 260. At this point, I'll skip the rest of the calculation because it is the same, and we get a final value of $3,813.33. Last one, E. We are compounded daily now, and we are going to deal with daily as 365 times per year. Yes, I know we have leap years, but we're not going to worry about is it a leap year or not. We're just going to go with a standard 365. Substitute in. P is still 3,000. 1 plus 0.048 divided by 365 to the power of 365 times 5. Again, skipping the calculation, because it's the same as it always has been, we get $3,813.69. So the compounding period does significantly affect the amount of interest earned. We go from a low of $3,792 at compounded annually to $3,813 compounded daily. It's only a $20 swing in this case because $3,000 is a relatively small amount of money and 5 years is a small amount of time. But as the amount goes up and the time goes up, that compounding period definitely does make a difference in the amount of interest.